Ladies and gentlemen, boys and girls, children of all ages. I'm not here. It's my son's birthday. Mr. Miller is in the classroom. Say hi to Mr. Miller. Mr. Miller, if you really want to make a good impression on these students, Lucy loves when you go and sit next to her. Sometimes when you walk just over her shoulder. Lucy, I know that you miss me and that you wish that I was there. So Mr. Miller, if you'll just sit next to Lucy, she'll really, really, really love that. Lucy, I hope you're looking at Mr. Miller going, please don't. Lucy, I miss you, but I'm going to see you guys all in a second anyway. Julian, you owe me the homework that was due last Friday. I hope you had a great field trip. Again, I'm going to be back in about 30 minutes, y'all. What I'm doing is eating lunch with my son. It's his birthday. I want to be that dad, okay? So, warm-ups on the board. We have M is parallel to N. Down here, so we have N, M, L. L is our transversal. It's cutting through those parallel lines. We have 4x plus 15. We have 3 multiplied by the quantity of x minus 15. Mr. Miller, at this point, if you will pause the video and give everybody about 5 minutes to get started on these, that would be great. Then press play and I'll start describing how we do it. So go ahead and please press pause now. Hey, welcome back, y'all. Man, that was a quick 5 minutes. Okay, so when we look at parallel lines, one of two things is happening. Either our angles are going to be congruent because of corresponding angles, because of alternate interior angles, because of alternate exterior angles, or they're going to add up to 180 degrees because of consecutive interior angles. But what happens when they don't? Well, in this case, we know that these lines are parallel. And when you get a worksheet, you're going to get a worksheet that has like these arrows on them that show that those lines are parallel. I told you the lines were parallel here. But when we have that, we can say, well, if this is 3x minus 15 and these have to add up to 180, well, this is also 3x minus 15. Why? Because these two are alternate interior. If those are alternate interior, they're congruent, which is why they're the same. And now we have a linear pair. Because we have a linear pair, we can say 3 times x plus, no, Mr. H, 3 times x minus 15 plus 4x plus 15 equals 180. Why? Because they are a linear pair. Linear pairs form a straight line. They add up to 180. Okay. I've got big ears. I just realized that they're great for holding markers. Here we go, balance point. We have to solve for x first. So we're going to multiply. That gives me 3x minus 45 plus 4x plus 15. Combine 3x plus 4x gives me 7x. Negative 45 plus 15 gives me negative 30 equals 180. From here, I'm going to add 30 to both sides. That leaves me 7x equals 210. Divide by 7. X equals 30. All well and good, but we're looking for the degrees, even though it doesn't say that. Maybe you did, maybe you didn't. I'm going to find the degrees now. So what do? I substitute back in. So I say 3 times 30 minus 15 degrees. So that's 3 times 15. So this is 45 degrees. By rights, without even doing anything, if this one's 45, we should be able to say that this is 180 minus 45, so this should be 135, if we've done it right. So now I'm going to do 4 times, 30 plus 15, that's 120 plus 15, that gives me 135. Lo and behold, it works. We now have angles that are making sure that those lines are parallel. If you have any questions, again, I'll be back in about 15 minutes. Go ahead, get out your notes, please. We are starting on distance and midpoints. As you're doing that, the objective for today is threefold. 1, we need to know how to graph ordered pairs. That's objective number 1, graphing ordered pairs. Number 2, can we use those ordered pairs to find the distance between the points? And objective number 3, can we find the midpoint between 2 points? Here we go. Daniel, If you need to, this video is already there. I know that we're still copying down, but make sure that you go back and rewatch it. Okay. If I go too fast, Mr. Miller, please let them know that they can ask to pause the video, but they already know that. They do a great job with that. Again, we don't have favorite classes. We certainly don't have favorite classes, and this certainly isn't mine. No, 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 no. Okay, so on Friday we had a couple questions that were just about finding ordered pairs. We have an x-axis, we have an y-axis. The way these numbers work are positives go up and to the right, negatives go down and to the left. So here's point A, here's point B. Point A is the ordered pair. I start at the origin, 1, 1. X-axis 1, y-axis 1. 1, comma 1, because our ordered pair is always x, comma y. This is a review from algebra, but you might not remember this. B starts at the origin, 1, 2. Oh, but that's negative, so it's negative 2, comma. Now we're going down 1, 2. That's negative 2, comma, negative 2. So now what I want to do is I want to graph 3, comma, negative 2. So how would I graph point C of 3, negative 2? Well, start on your origin. My x, because it's always x, comma, y, and that's going to be important for today. I go over 1, 2, 3. I don't put a point yet, because now I have to jump down 1, 2. And there's point C. Okay? You need to know how to do ordered pairs. Why? Because we are going to use ordered pairs for the distance formula. We are trying to find the distance between 2 points. So if I connected these 2 points, can I find the measure, that length of that line? To do that, we are using this equation. D equals the square root. Okay? And I'll show you how to do all of this on your calculator. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Everything is underneath that square root. Is there a glare? Are we able to see all this? Oh yeah, you're able to see all this. Okay? So, what does this mean? Well, without a coordinate grid, here's my coordinate grid. Without a coordinate grid, how can I do this? 3, comma 4, negative 2, comma 5. We are going to find the distance between these points. Now, the first thing that we're going to do is say, which point is first? Well, we read from left to right. This is my first point, this is my second point. So we label. We say x1, y1, which means this is x2, y2. And now we're going to substitute it in to our formula. We say x2, which is negative 2 minus x1 squared, plus y2 minus y1 squared. So now we're going to get our calculators. Okay? So we do negative 2 minus 3. And notice, this is in parentheses. That's negative 5 squared plus 5 minus 4 is 1 squared. Now, here's where it becomes tricky. If it's in parentheses here, it's going to stay in parentheses in your calculator. So, I find my parenthesis button. I press negative 5, I close the parenthesis. Then I can do my x squared button, which is next to the 7. I press enter. Notice how it gives me positive 25. If you get negative numbers when you square them, you've done something wrong. 25 plus. Do the same thing for 1. Parenthesis. 1 parenthesis x squared. Enter. And I get positive 1 again. So now I have the square root of 26, because 25 plus 21 is 26. We can't get an equal. We're going to get an approximate. So to do the square root, I'm going to press this button that says second. Then I come down to the x squared button, which has a square root. I put in 26. Uh-oh. Come on, Mr. H. Mode. How do I do that? Hold on. Oh man, I don't know how to use these calculators well enough. So we're not going to do them. Some of you might be able to get them to decimal. I'll have to look to see why this one doesn't, because I know this calculator does. Let's try this one. Maybe I'm wrong. Let's try this one. Here we go. So we're going to go second. Turn it on, Mr. H. There we go. Second, x squared 26. Press enter. This one gives me a decimal of 5.099, which is approximately 5 1/10. If your calculator doesn't give you a decimal, just leave it like this. Okay, so those are my two answers. This is exact. This is the approximate. Let's do another one now that I've screwed that all up. Shoo! Should have checked that calculator first. Here we go. This is all about substituting in. All about substituting in. So let's do one more. Find the distance. D equals what? When? -2, -7, -3, -8. Here we go. This one should be easy. So we're going to go D equals the square root of x2, x1, y1, x2, y2. x2 is -3 minus x2, or x1. -3 minus a -2, plus y2 minus y1. Okay, so now when we do this in the calculator, you have to be careful. -3 minus a -2. That gives me, oh, don't forget the squareds. Mr. H, you're screwing this all up. Gives me -1 squared plus -8 minus a -7 gives me -1 squared. So now, use your parentheses, -1 parenthesis squared gives me +1. So now I have +1 plus 1, which is the square root of 2. Or when you do the square root of 2, it gives you approximately 1 4/10. That is the distance formula. Okay? I'm going to give you a second to copy that down. Hey y'all, I'm almost back. I'm probably like throwing garbage away at my son's school right now. I'm not going to tell you that we ate Chick-fil-A. No, I'm not going to tell you that. I'm not going to tell you it was delicious either. I don't know that yet, but I'm assuming that it's going to be delicious. I think I can assume that it's going to be delicious. It's always delicious. Okay. One more thing that we're doing for today. One more thing. We are going to learn about the midpoint. So you all know what the midpoint is. That's the halfway point between 2 points on a segment. But today we're going to learn the midpoint formula. This works when it's again on a coordinate plane and we have no idea how to find that halfway point. So we're going to say the midpoint M is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Can you get decimals for a midpoint? Absolutely. So here we go. We've got 7,4, 9,22. So first off, x1, y1, x2, y2. we have 7 plus 9 divided by 2, comma, 4 plus 22 divided by 2. That gives me 16 divided by 2, comma, 26 divided by 2. That gives me 8. That gives me 13. My midpoint is 8, comma, 13. Okay, that's the halfway point. All we're doing is substituting in. The midpoint is the easier of the two, but you're going to want to have these two things copied down, maybe highlighted, something going on with this. Let's use this same one right here. So now we're using this for this one. We already have x1, we already have x2, we already have y1, we already have y2. So I'm going to say 3 plus a negative 2 divided by 2, comma, 4 plus 5 divided by 2. Okay, 3 plus negative 2 is 1 divided by 2, comma, 9 divided by 2. If you want to leave it as simplified fractions, this is it. Or we can say, as a decimal, 1 divided by 2 is 5/10, comma, 4 5/10. When we are graphing, it's probably easier to see it with decimals. But all you're doing is substituting in. You do have a worksheet to work on. You are doing problems. Let me look here. On said worksheet, you are doing problems number, come on, Mr. H, find it. Numbers 1 through 15. You are doing numbers 1 through 15. Mr. Miller, if you'll hand out those worksheets to let them start working. Kiddos, I love you, and I should be back shortly.